This Pythagoras theorem question here involves us working in 3 dimensions. Now we're told that the Great Pyramid of Giza has a square base of length 230.3 metres and the vertical height is 146.6 from the centre of the base to the apex. And it's our job to find out the length of this sloping bit here. Now you can see how it's in 3 dimensions. You might also realise that this triangle here, even though it doesn't look like a right-angled triangle, it would be a right-angled triangle if you kind of went to the original and you imagine someone dropping a plumb bob from the centre down through the inside. It's going to hit the ground at right angles. So sometimes when you draw things obliquely, things that look like they're not right angles are actually right angles. And that's the case that we've got here. So we're going to be able to use this triangle here. But you can see that we haven't got enough information about it. We're trying to find out L. We know this side, but we don't know that one. What I'm looking at now is this base here, this square base. Because I do know that's 230 and that's 230. And I know this is a square too, even though it doesn't look like it. Sometimes it's a good idea in this type of question to redraw things out as you're working with them and straighten them up. So that's, if we were looking straight down from on top at that square base, that's what it would look like. Now I can use that to work out this distance here. This is my plan. If I can work out this distance here in this right angled triangle, that's the distance all the way across here, then I think that the distance from here to here is a half that total distance. So I will know that distance there. Then I can look at this triangle here, which is also right angled, and I'll know 2 sides. I can work out the third. Okay, so let's call this diagonal line here x, and we can say that x squared is equal to 230 squared 0.3 plus 230.3 squared. Now I've done some calculations beforehand here, so I know that means x squared equals 106,076.18, squaring them and adding them together, and taking the square root to find out x is equal to 325.69. Now that's the distance all the way across here. I'm not interested in that total distance, I'm more interested in this half distance across here. And so I might say, therefore, and I'll call this distance here y, is the distance from there to there. Y is equal to a half, or 0.5, times 325.69. And that meant that y equals 162.85. Okay, now we've found out this distance here equals 162.85 from the centre to the outside. I can now look at this triangle here, which in fact is right angled. I'll redraw it here. That distance is 162.85. It is a right angled triangle, and the height is 146.6. I can now use ordinary Pythagoras' theorem to work out that distance L, which we were asked for. So I can say that L squared equals 146.6 squared plus 162.85 squared. It's a plus question because I'm trying to find the hypotenuse. A little bit of maths in between. Square this, add them together. That's L squared, and of course take the square root of both sides, and I'll find out L equals 219 0.11.